equals that other thing. Okay. So one of the problems in the homework set, this is actually the Unit 4 problem, number 14. This is a C3 type problem. What we're doing in this problem is we're drawing vectors graphically, and we're drawing this scale diagram graphically in order to solve for some vector components. So, or for some vector resultant. So what we're doing here in this problem is we have two vectors, vectors A and vector B. And vector A has a magnitude of 50 meters, and it is pointing 20 degrees below axis, the x-axis. Okay, 20 degrees below the x-axis we could write in two ways. We could either write that as 340 degrees if we're assuming that we're in quadrant 4, or we could write this as negative 20 degrees. Remember, if you're going around the unit circle counterclockwise, that's the positive direction. Clockwise is the negative direction, so that's how we can get the negative 20. Let's just stick with the 340 though. So we've got vector A. And vector B here, we'll make this in blue. Vector B has a magnitude of 70 meters, so it's a longer vector, and it's at a direction 50 degrees above the x-axis. Okay, so if we're going to put this in the first quadrant, then it would actually be at 50 degrees. So those are our two vectors there. Okay, if I were to plot these, there's my axis, and once again, this is to scale. So maybe over here, I set my scale, 1 centimeter equals, I don't know, 10 meters maybe. It's really up to you and the space that you have. If you make this number here bigger, then you need to draw fewer centimeters. Your vector, when you draw it, will actually be smaller. If you make this number smaller, then you're actually going to increase the length of your vector. So that's something to be aware of. But if I draw these two to scale and using my protractor, remember, I carefully use the protractor to come up with how far along this vector will be plotted. I place a dot there, and then I draw the line the correct distance. So in this case, maybe that's 20 degrees. And then let's use a line function for this. There we go. Maybe this is vector A. Okay? So we've got vector A right there. And we are simply saying that in this case, this angle here is 20 degrees. Okay? If we plot vector B carefully, it's a slightly longer vector. Oops, what's going on there? So slightly longer, pivot that around. And it's at 50 degrees here, so maybe it's pointing kind of up like that. Okay. Naturally, when you do this on paper, you're drawing to scale, so you're super accurate. You know exactly what you're doing with your ruler and protractor, so you can do that. Okay. So down here, this is vector A. This up here is vector B. Now, the issue what we have here is that these two vectors are plotted tail-tail, and we're just not allowed to do that. They have to be head-tail when we plot all these. So what you can do here to make your life easy, and what I like to do when I'm doing this with a ruler and protractor, is place your ruler on either vector A or vector B, lay it there, and then without twisting your ruler at all, just slide it along so that you're matching up with the other vector so that you can get the head-tail method. Let's see if I can do a select option here. What we're looking to do is we're looking to move vector A, and we're looking to move it up here so it points along like this. So we're looking to take vector A and just sliding it up. We now see that that is head-tail, and this is vector A. If we wanted to, we could have also brought vector B over. So that vector b would kind of be going up like that. Now you can see, just drawing this, I'm not exactly perfect, but because all of these lines, well, vector b's should be parallel, vector a should be parallel. We can see I'm kind of off. That's a normal thing if you're a little off. You're drawing this by hand. You're doing your best. We sneeze. Stuff shakes a little bit. But then we simply go start to finish. So start to finish, that's my resultant. Measure that in order to get the length. Okay? So you'd measure it. You'd use your scale in order to get something from that. And then you would get an angle from the positive x-axis up, and that's your angle theta. So in the end, you're going to have length, comma, theta, and you're done. Okay? So that's how you would do kind of problem 14. Now, so that's 14 there. Fin. Okay? So that's what you would look like. You're looking for the measurement of the length. That length and the theta goes in. Okay?